This now takes us to what is known as the order or size of a set. The size of a set determines the number of elements in a given set. This concept is also known as the cardinality of a set, which basically means the number of elements in a set. So this concept should not be confused with the arrangement of a given set. So as we saw in the previous example, A equals, I'm writing this in red because it's a pitfall. So many students tend to confuse between these two concepts. So A equals 1, 2, 3, 4, and 5. This is known as the ascending order in mathematics in general, meaning that you begin with a small number and you go to the larger number, right? From the lowest to the highest. And then if you have A as 5, 4, 3, 2, and 1, this is known as the descending order in mathematics. So you begin with the largest number, the highest number, to the lowest, descending order. So this concept of arranging the numbers, right, whether in ascending order or descending order or in whichever random order, is not the same as what we call the order or size of a set. The order or size of a set, otherwise known as the cardinality of a set, cardinality, I've highlighted it here, it means the number of elements in a given set. So this is very important. Other important notations are, as we said, in the set theory, there are so many notations. It's all about notations. You have to understand the notations before you can solve many questions. So E, which is the epsilon, it's also written in this way, means element. So for example, we could say 1 is an element of A. Instead of you writing this in Word, this whole statement, you could write it in this way. This is much shorter. So 1 is an element of A. You could also say 2 is an element of A. Likewise, 3 is an element of A. This is a very important notation that you don't only find in the set theory, but in mathematics in general. The next set notation that we have is the subset. This is known as the subset. It's like a U that is inverted and facing right to the right. So it faces to the right. While superset is also like a U, but then it faces towards the left. Let's now take some examples to further cement our understanding. If set A equals 1, 2, 3, 4, and 5, and set B equals 2 and 4, set C equals 1, 3, and 5, we can say that B is a subset of A. Why is that the case? Because the elements that are found in B can be found in A. So 2 can be found and 4 can also be found. So B is a subset because it can be included. So say for example you had A like this is a Venn diagram, then B can be embedded in A. So this is why we call it a subset. Likewise, C is also a subset of A and is represented as C subset A because you have 1, right, in A, you also have 3 in A, and you have 5 in A. So all of the elements that are found in C are all found in A. So this is why we could say C is a subset of A. The next thing is the superset, which is like the opposite. So A is a superset of B, meaning that A contains B, right? A is a superset of B because A contains B. Likewise, A is a superset of C because A contains C. When I said this is like opposite, what I mean by that is this is the, you could say this is the first case and this is the reverse case. So A is a subset of B, meaning that A contains B, and A is a, sorry, superset, I meant superset, and A is a superset of C, meaning A is a contains C. So the remaining set notations or symbols will be explained in the upcoming videos.